Good morning, students of grade 10. Today we are going to continue what we have left from yesterday, force. Okay, yesterday we derived an expression related to Newton's universal law of gravitation, and today we are going to discuss about how the amount of gravitational force vary when mass or distance between them are changed. Like here is a mass and here is a second mass, yes, and they are kept separated by certain distance, and in that case they will experience certain amount of force, let that be F. Then what happens if you increase the mass of one object, or what happens if we decrease the mass of one object, or what happens if we increase the mass of both object, or what happens if we decrease the mass of both object, what happens if we increase the distance or decrease the distance between them? Will the gravitational force remain same or different? Obviously it will be different. Just take an example of magnet. You have a magnet here, okay? You take two magnets with their opposite poles facing to each other. What happens if you use a bigger magnet or more stronger magnet? Obviously you will experience more force. If you use a bigger magnet on both sides, then obviously it will even exert even more amount of force. If you bring it closer, then also magnetic force will increase. Or if you decrease the distance, it is increase the distance, you take them far away from each other, the magnetic force will decrease, isn't it? Or if you decrease the size of magnet, magnetic force decrease. Just like that, this is just an analogy. Just like that, in case of gravitation also, gravitation basically depends on mass of the bodies and distance between them. That means if distance between them is increased or decreased, force of gravitation changes. Or mass of one or both bodies are changed, then force of gravitation also changes. Okay, so we are going to discuss in several cases, like cases. Case number 1, when mass of one body is doubled. What happens when mass of one body is doubled? We are going to check that. And second one, when please copy these questions, mass of one body is halved. Okay, once you understand one of them, then you can easily do all of them. Okay, so I'm going to do only few, not all. Rest you have to do. When mass of both body are doubled, and when mass of both body are halved. Okay, these are in terms of mass. Similarly, when mass of one body is doubled and another is halved. Okay, these are the questions or cases related to mass. Okay, when mass of one body is doubled, what happens to gravitational force? When mass of both bodies doubled, what happens? Mass of one body is halved. What happens to the gravitational force? When mass of both bodies are doubled, what happens? When masses of both bodies are halved, what happens? Or when mass of one body is doubled and another is halved, what happened? Okay, among them I'm going to do only any two of them. Okay, rest of them you have to do on your own. That's why copy all of these cases. You can freeze the screen, you can pause the screen. Okay, now another case related to distance. What happens when distance is halved? So distance is doubled, and when distance is halved. Okay, another case relating to both mass and distance. That means when distance is halved, okay, and mass of both bodies are doubled. Similarly, just opposite to that, when distance is doubled and mass of both bodies are halved. Okay. Similarly, you can make other distinctive cases like when distance is tripled. Okay, distance is tripled. One of the mass is doubled and another mass is reduced by 3 times. Okay, this is some advanced question. Okay, if you can try this as well, but as an example I'm going to do certain cases, like I'm going to do this one when mass of one body is doubled. Okay, and then I'm going to do selectively when mass of both body are halved. Okay, this one I'm going to do, and then when distance is doubled. Okay, if you need and then after, okay, this one. Okay, these 4 cases I'm going to do these 4 cases, and rest are up to you for exercise or practice, and the same is going to be your assignment for today. Okay, now let's go to our case number 1. Okay, case number 1, what we are going to do, case number 1, when mass of one body is doubled. Okay, when mass of one body is doubled. Okay, the opening, let us suppose 2 bodies have mass m1 and m2 and separated by distance d. This is our usual case. Yes, in usual, mass of one body is considered m1, mass of second body is considered m2, and distance between them is considered as d. Then according to Newton's law, what we have, F is equals to g m1 m2 by d square. Let us leave here. We don't need to do any further about this. Now, what the question says, when mass of one body is doubled, you need to double only one body. Yes, when mass of one body is doubled, then what happens? m1 is replaced by twice of m2. Twice of m1. Okay, instead of m1, now we have to place twice of m1. Then new gravitational force be F dash. Okay, F dash indicates the new gravitational force, because definitely by increasing mass of one body, amount of gravitational force is going to alter or change, and that different form gravitational force, altered gravitational force, is indicated by F prime. Then it will be G, what we said, m1 is replaced by twice of m1. So instead of m1 we are writing twice of m1, and rest of the factors are not changed, they are unaltered. Okay, so these two I can separate it so that I can make this group. I'm going to recover this expression here. In all of the questions we are going to do same. We always try to recover this expression over here. Okay, so according to here, only 2, this 2 is an extra item, so we separated it, and rest of the items are grouped together as original. See, now this is the same. Yes, therefore F dash is equals to 2 into, and this expression G m1 m2 by d square is actually original F. See, so we got that if mass of one body is doubled, when mass of one body is doubled, then gravitational force between them is also doubled. Okay, this is our answer. You can give conclusion. Therefore, when mass of one body is doubled, then gravitational force between them is also doubled. Okay, up to here, do you understand or not? Please check once again. Okay, now you can freeze the frame and copy it. Okay, now we are going to another case number 2. Okay, I'm going to do case number 4 as an example. Yes, okay, case number 4. 2 and 3 you have to try on your own. You also have to do something. Okay, do not rely only on me. Okay, that's it. Okay, what does case number 4 says? When mass of both bodies are halved. Okay, when mass of both bodies are halved. Okay, our opening statement is same. Let us suppose masses of two bodies be m1 and m2 separated by distance d. Okay, then according to Newton's law, universal law, according to Newton's universal law, what you get? F is equals to g m1 m2 by d square. Let us leave it here. Okay, now when masses are halved, then see both m1 and m2 are going to change. Okay, in previous case only one object was altered, but now we are going to alter both objects. Okay, both objects, mass of both objects are halved. That means m1 is replaced by, what should you do? m1 by 2, and m2 is also replaced. m2 is replaced by m2 by 2. You can see since mass of first object is halved, m1 is replaced by m1 by 2, and since mass of second object is halved, m2 is also replaced by m2 by 2. Then our new gravitational force F dash will be g into, instead of m1 we write m1 by 2, and instead of m2 we write m2 by 2. D remains same, or F dash is equals to g into, now you can write it like m1 into m2 by 2 times 2 is 4, all divided by d square. Now see, the denominator of numerator, where does it go? It definitely goes in denominator. Okay, that is very easy, simple mathematical rule. The denominator of numerator goes to denominator. Okay? So rest of the terms you can keep it in group. Okay, once again see, this group g m1 m2 by d square is actually original force. Therefore what you get, F dash is equals to 1 by 4 into F. Answer. So it shows that force decreases by 4 times. It is divided by 4 means force is decreased by 4 times. Now give conclusion. Therefore when mass of both bodies are halved, force of gravitation decreases by 4 times. Okay, so this much. This one is case number 4, and as a case number 4 says, okay, you can freeze screen if you need to. When mass of both bodies are halved, what happens? Let us suppose masses of two bodies be m1 and m2 separated by distance d according to Newton's universal law. F equals to g m1 m2 by d square, when masses are halved, m1 is replaced by m1 by 2 and m2 is replaced by m2 by 2. Then f dash is equals to g into m1 by 2 into m2 by 2 divided by d square, and f dash equals to g into m1 into m2 by 4 divided by d square, and f dash equals to 1 by 4 into g m1 m2 by d square, and therefore f dash is equals to 1 by 4 into f. And when mass of, therefore conclusion, when mass of both bodies are halved, force of gravitation decreases by 4 times. Okay, now let's go to next case. Okay, next we are going to do case number 6. Okay, in case number 6, what does it say? When distance is doubled. Once again, I'm not going to do all. Okay, you have to practice. When distance is doubled, what happens? Okay, once again, opening statement is same. Let us suppose masses of two bodies are m1 and m2 separated by distance d, and according to Newton's law, what we get? F is equals to g m1 m2 by 2. Let it be equation number 1. Now when distance is halved, only distance is altered. So distance is doubled, only distance is changed. Yes, only distance is changed, but masses remain same. That's why we only need to replace d. D is replaced by twice d. Distance is doubled. Yes, then new force of gravity F dash become g m1 m2 by d square. Yes, twice d whole square. You usually forget to put bracket. Okay, or don't forget to put bracket. If you don't put bracket, then what happens? G m1 into m2 by, instead of d you put twice d, and then you simply put square, and while you separate it, what happens? 1 by 2 into g m1 into m2 by d square, and f dash equals to 1 by 2 into f. You will find this answer. Yes, it shows that force decreases by 2 times, so force becomes half, but this is wrong. Okay, this is wrong. Okay? Because if distance is double, then since force is inversely proportional to square of distance, if distance is double, then force must be affected by 4 times. Okay, now f dash is equals to g m1 into m2 by 2d square, means 4d square. Or now separate the terms, as I already told you, we always going to form a separate group of these terms, g m1 m2 by d square, original terms. So by doing that, we get 1 by 4 into g m1 m2 by d square. Therefore f dash is equals to 1 by 4 into f. Understood? Okay, therefore give conclusion. Therefore when distance is doubled, force of gravitation decreases by 4 times. Okay, this one is quite easy. Yes, not so difficult. When distance is doubled, see, d is replaced by 2d and it gives 4d square, and separating 1 by 4, you get f dash is equals to 1 by 4 f. Okay, if you need to copy, then freeze screen or pause the screen and then copy it. Now in case of case number 7, I'm just going to give you a hint. I'm not going to do it. Case number 7, what says? When distance is halved. If distance is halved, then what you should do? D is replaced by d by 2, isn't it? Yes, so your new force of gravity would be something like this: g m1 into m2 by d by 2 square. Okay, I did this from this step. Okay, I did this only from this step. Okay, and the opening statement would be same. Okay, in this case, what you get, g m1 into m2 by d by 2 whole square means d square by 4. Okay, always doing mixed double fraction, d square by 4. Okay, d square and 2 square means 4. Now see, there is a fraction in denominator, and always remember the main fraction must be at the same line as that the equals to sign. The equals to sign must be at the same level of main fraction. This is the main fraction. This is not main fraction. If you are going to write something like this by d square by 4, if you write like this, see, it shows that this is the main fraction, but that's not it. Okay, this is the wrong way of writing it. Got it? You always must put equals to sign in the same level as the main fraction. Now see, this is the fraction in denominator, and how do we deal with things like that, situation like this? The denominator of denominator would go to numerator. Okay, that means or you can also deal it like this, m1 into m2 into the fraction of denominator is always reversed. D square by 4 becomes 4 by d square. Okay, now you can separate the terms like this, 4 into g m1 into m2 by d square, and it gives us therefore f dash equals to 4 into f. Okay, you can deal it like this. Okay, many students get confused at this step. Okay, sorry, this step. What to do after this? How to deal with the fraction in fraction. Okay, many students are generally confused at this stage. Okay, I hope you will not get confused at this stage. Now there is one more case I'm going to do for you. That is question number 8, case number 8. Okay, and the rest you have to do on your own. Okay, case number 8, when distance is halved and mass of both bodies are doubled. Okay, it gives us general rough idea. Okay, it can give us rough idea. If distance is halved means gravitational force must increase by 4 times. Okay, and mass of both bodies are doubled means 2 times 2 4 times 4 16. So its answer must be 16 times. Let's see if we can get that or not. Opening statement, let us suppose masses of 2 bodies be m1 and m2 separated by distance d, and according to Newton's universal law, F equals to g m1 into m2 by d square. Okay, let it be equation number 1, because from here we need to substitute the value of f. Okay, now when distance is halved, what we have to do, d is replaced by d by 2. Okay, one of the cases here, and there is another one also. Mass of both bodies are doubled, and when mass of both bodies are doubled, then you know what to do. m1 is replaced by twice m1 and m2 is replaced by twice m2. Okay, then what you get, new force of gravity F dash is equals to g into, instead of m1 you put twice of m1, instead of m2 you put twice of m2, and instead of d you put d by 2 and there is square as well. Okay, now let's solve this. Or f dash is equals to g into 2 times 2 is 4 m1 into m2 divided by d by 2 square means d square by 4. Or f dash equals to, I'm going to put 4 in front of everything, 4 into g m1 into m2. And I already told you how to deal with this fraction within fraction, d square by 4. How to deal with it? We do like this, into d square by 4 becomes 4 by d square. Okay, or now we can multiply 4 and 4, that we get 16, and rest of the terms we can form a group like g m1 into m2 by d square. Now this term is, you all know this is f. See, therefore f dash is equals to 16 times of f. Now give conclusion. Therefore, when distance is hot and mass of both bodies are doubled, gravitational force increases by 16 times. Okay, so if there are any confusion, please go through the video once again. Okay, say watching the explanation 2 or 3 times might help you to get the concept, and if by doing that also if you get confused, let me know about it. Okay, I'll try to clear your confusion either through messenger. Better you do contact me through messenger. You can post your confusion in comment section as well. Okay, that's all for today. All you have to do is please go through the cases once again. I hope you have already copied the cases. Okay, I gave you 10 cases already. Yes, please go through the cases. I have done 4 cases. I have elaborated 4 cases here. Please go through them once again and try to do them again without taking any help, and then do all other cases as well. Okay, solve all 10 cases from here. Okay, that is your assignment for today. Thank you very much.